Inverse trig functions are generally used to find missing angles. So you'll notice that I have some angles over here on my triangle, and I have two of the side lengths labeled. My first angle I'm going to refer to as alpha, and my second angle I'm going to refer to as theta. Generally, angles in trigonometry are Greek letters. When you see an inverse trig function, they look like this. So sine -1 of theta, for example, or cosine -1 of theta, and of course tangent -1 of theta. Now, something that's nice about these inverse trig function is that they undo their opposite. So, for example, sine -1 of sine of theta, sine of -1 undoes the sine, and all that's left is the angle, and that works for each of these. Therefore, we can actually figure out each of these angles just by knowing two of the sides. Now you'll notice, if you look at your calculator, that the inverse trig functions are right above the regular trig functions. So to use those inverse trig functions, you press second, and then either sine, cosine, or tangent, depending on which one we're using. All right, first I want to find alpha. So I want to find this angle right here. For alpha, I know that 10 is the opposite side and 16 is the adjacent side. So I'm going to be using tangent here. Now I'm going to set this up originally the same way we have been. So tangent of alpha equals, and then opposite, which is 10, over adjacent, which is 16. The difference here, though, is we're solving for alpha. So to solve for alpha, I need to get rid of tangent. Therefore, I'm going to take the inverse of this side, and just like with any algebra, if you do it to one side, you have to do it to the other. So I'm going to do it to the other side. Let's get rid of this real quick. So I'm going to take the inverse tangent function of 10 over 16. On the left-hand side, these cancel each other out. All we have left over is alpha. And on the right-hand side, this portion goes right into the calculator. So tangent, inverse tangent of 10 over 16. So inverse tangent, which is right up here, of 10 over 16 is going to give us 32, and if we round that to the nearest whole number, it would be 32 degrees. I am in degree mode. So if you got something different from your calculator, you might want to check to make sure you're in degree mode instead of radian mode. Excuse me. Now let's say we're trying to find the tangent of theta. Well, again, we're going to be using, sorry, not the tangent of theta. Let's say we're trying to find theta. Again, we're going to use tangent because we're dealing with opposite and adjacent. In this case, though, 16 is the opposite side, and 10 is the adjacent side. So this time, I'm going to say, all right, tangent of theta equals, I'm going to leave space, opposite, 16, over adjacent, which is 10. And again, I want to get rid of tangent, so I'm going to use the inverse function, which is going to leave me with theta. I just type tangent, inverse tangent So inverse tangent of 16 over 10, and that gives me 50, if I round, about 58 degrees. And now if I add theta and alpha and my 90-degree angle, I actually do get 180 degrees. So this does work correctly. One last thing. If you want to express a side as an inverse, so if I want to express this angle as an inverse, I could write that angle, alpha, as the inverse tangent of, and then tangent would be opposite over adjacent here, so 10 over 16. So this is another way of expressing angles. So if you ever see something saying theta or alpha or beta or whatever equals, and then an inverse trig function and a fraction, even if that fraction contains variables, that's referring to an angle. And that is it. And you can use these sides here to figure out which angle it's referring to. So since this is the opposite, this is the adjacent of alpha, you can figure out, and it's a tangent function, you can figure out where alpha is.